All right, which molecule or ion has the smallest ONO angle? Okay, think about that for a second. The smallest ONO angle. Well, how do we determine that? We need to draw Lewis dot diagrams, right? Okay. This is nitrogen plus 2 oxygens. This is 5 electrons plus 12 electrons. This is a 17 electron system. So, now we have, we've used 2, so we'll put these 2 pairs. So that 2 pairs leaves us with 5 pairs. We had 17, so that's 16 and 1 is 8 pairs. We used 2 of the pairs, so we have 6 pairs left. Okay, and a single electron right here. Okay, now keep in mind that this is only 2, 4, 5 electrons around the nitrogen, so probably we're going to make a double bond like this. And then there will be another resonance form where the double bond's on the other side. The question is, what kind of bond angle can we expect for this? And the answer would lie in the shape class of the nitrogen, okay? So with this nitrogen right here, what shape class do we expect for it? How many electron groups are there? There are 3 electron groups, right? You count that one. That's one lone electron counts as a group. So there's this one, and this one. So it's an AX3 case, and we would expect the ideal angle to be 120. But now we have some complicating factors here, and we have a double bond and a single bond and a single lone electron there. So it's not really very clear-cut how the deviation will go. Okay, so we'll just leave it at 120 for a little bit. Now, if we take NO2 minus and we do the same thing, we're going to get the same result, except we're going to have a pair of electrons here now. It just has one more electron. Okay? Now it has one more electron, so there's a pair of electrons here instead of a single electron. So what do you think that will do to the bond angle of this one compared to the bond angle of that one? This is smaller, good. It'll make it smaller. This one will be smaller than that one, just reasoning 1 electron repelling versus 2 electrons repelling. 2 electrons are going to win. Okay? Now, NO2 plus has 16 electrons. 16 electrons is just like something else we know. Can anybody tell me what looks like this and has 16 electrons? CO2, right? NO2 plus is isoelectronic for CO2. How did I know that without counting? Well, if you look at the nitrogen is 1 step to the right of the carbon. So if you take nitrogen, it has 1 more electron than carbon, and therefore NO2 plus would mean the removal of that 1 electron. So NO2 plus is isoelectronic with CO2 and it'll have the same structure. So what will be the structure of this? How many electron groups? 2. This is an AX2. What's the bond angle? 180. So clearly the one with the smallest bond angle is NO2 minus, because 180 is larger than 120. So this is going to be the worst one as far as bond angle goes. It's going to have the largest bond angle. And then this one will be next, NO2 will be next, and NO2 will have this, NO2 minus, which is the nitrite ion, will have the smallest bond angle. Okay, does anybody have trouble following that, or do you need clarification? Yes. Two electrons. NO2 minus has one additional electron over NO2. NO2 plus has one less electron. So NO2 minus has 18 electrons. NO2 has 17 electrons. NO2 plus has 16. And that makes all the difference in the Lewis dot structures. Okay? Because NO2 plus only has 2 electron groups. And that means a linear structure. The other two have 3 electron groups. And so that'll be a derivative of a trigonal planar. Yes? Yeah, you just have to add or subtract according to the charge. You're right. Other question on this one? Okay, let's look at this part down here. Which molecule has the smaller CCC angle? In other words, this one right here. This angle versus that angle. Well, the central atom that we're worried about then is this carbon versus that carbon, right? Both of these have 2 single bonds and a double bond around them. 2 single bonds and a double bond. Now, let's focus on the effect of the double bond, because we know the double bonds repel more strongly than single bonds. We know that. So if that is the case, then this double bond is going to repel those 2 single bonds and make this smaller than 120 degrees. Now, if this is smaller than 120 degrees, then this angle is going to be greater than 120 degrees. Everybody see that? Okay. Now over here, the double bond is going to repel these 2 single bonds and make this angle less than 120 degrees. So this is the acetone molecule. We did it in class. And as you can see, it will be the correct answer. It will have the smaller bond angle because the double bond is on the other side of that particular angle, so it's going to squeeze that one down. Whereas over here in this molecule, which is propene, the double bond will widen that angle.